Hi everyone. This is the first in a series of review videos to get you prepared for your semester exam. Today we're talking about the difference between science and engineering and what scientists do as opposed to what engineers do. So we'll start with engineers. Engineers design technology to meet people's needs. Scientists they design experiments to answer questions. Now, both use what we call a systematic process to do this. Both use a systematic process. Okay? And basically a systematic process is one where you have a step-by-step method to approaching your experiment or your development of design in technology. You're not just haphazardly doing things, you have a method to the approach and to the completion of your task. So basically, engineers create technologies to improve our lives, okay? And they sometimes can have negative impacts. An engineer's decision to make something is driven by people, by society, by laws and policies, and what people want and need and things like that. Okay? Now, what does the engineering design process look like? So let's look at the engineering design process. Starts with identifying a problem. Identify a problem. Okay? Once you have a problem identified, you are going to identify the criteria. So the criteria is what standards do I have to meet? What does this thing need to be able to do? And constraints. So constraints are things that limit you. For example, a constraint of the Pfizer vaccine is that it has to be stored at negative 90 degrees Celsius. That's a constraint. You can't have it warmer than that. So these are like the requirements. Then you are going to brainstorm solutions. Select one to test. Build a prototype. Or a computer model, whatever you have available to you. Test the prototype. Iterate. Iteration means make it better, try it again. Like trial 1, trial 2, trial 3. Iterate. iterate and or repeat with revised design. Make it better. Okay? And then once you have a viable development, then you communicate the solution to the problem. Okay, so that is the design process. Identify the problem, what are the criteria, like what standards do I have to meet, and what are my limitations, my constraints. With those, you brainstorm some solutions, you choose one of your ideas to test, you build the prototype, you test it, you see if it meets the criteria and if it can hold to the constraints. Then you iterate to make it better. How do you make it better? Well, if it's not meeting the constraints or the criteria, you try to do that. You make it cheaper. You make it faster to mass produce. There's multiple ways to revise or make something that you've designed better. And then you communicate the solution. Okay, so that is the engineering design process. So this is sort of a circular pattern where there is a sort of hand-in-hand working together between scientists and engineers as things are being developed. So we'll start at the top, and this was part of your review. I'm just going to rewrite it and sort of just to refresh your memory. So we start with, actually I'm not even going to do that. We don't even need this. We start with scientists. Make a discovery. They notice that something is happening in a pattern, okay? That leads to engineers begin to develop a design for whatever the scientific discovery is. That leads to engineers developing new questions, which they send off to the scientists to experiment with. So scientists do further tests and the scientists then share that with the engineers who improve their design and develop new technology. And then it goes right back to scientists making a new discovery, and the whole cycle starts over again. Now, part of being an engineer is not only developing a new technology, but also explaining or taking into account the cost-benefit analysis of whatever technology it is that you're developing. Okay, so let's talk about cost-benefit analysis. Cost-benefit analysis is just basically assigning a dollar amount to how much it would cost for you to make this new item, new technology, whatever you're building, and assigning a dollar amount to how much benefit you would get out of it, and then kind of weighing those out and saying, is the benefit greater than the cost? Because if the cost is greater than the benefit, then it's not worth it. Okay? So we'll say a dollar amount is assigned to cost, benefit, and risk. Okay, so then you subtract the cost and risk from the benefit to get a net benefit. Net benefit. So, what does the cost include? The cost would be, for example, the price of the materials, the energy you're using to produce your technology. A risk is like environmental effects, like long-term environmental effects, people's health, etc. And then a benefit would be how much you would make by selling whatever you've developed. Money the company would make. So money company makes.
Hi, I'm barely.
I'm making a video. Just drop it and go, thank you. So the money the company makes. So if you take all of those costs and risks and you subtract the benefit, then you can kind of gauge whether this is going to be a profiting technology or not. So think about right now, for example, the COVID-19 vaccine that they're developing. Of course, it's super necessary, but you still have to do a cost risk benefit analysis to make sure that the vaccine is not going to cost billions and trillions of dollars without providing you the benefit that you need. Okay? There are different types of engineering. There's systems engineering, and where you look at energy and matter. So we'll say, let's write it down, systems engineering. You might want to go back and review this whole idea of systems engineering, because I just can't put it all in the video. But it's just basically the relationship between energy and matter. And looking at feedback loops. Right? Positive and negative feedback loops. So where in positive feedback loops you increase the change in the system and you make the system less stable. So positive feedback loops increase change, make less stable. And negative feedback loops, you decrease the change and you make them more stable. Okay, so look through those when you get a chance. So systems engineering focuses on making all the subsystems work together. Whereas other types of engineering work on designs of smaller parts or subsystems of larger systems. That's what the definition is. You just need to sort of know that systems engineering has to do with the relationship between energy and matter and this idea of feedback loops. Now, there are several key terms that you should know, and I'm not going to define them all for you, but I am going to list them, and I do want you to know them. Know what engineering is. We just went over it. key terms. Engineering design process. Okay. Criteria. Constraint. Cost benefit analysis. We just talked about that. And then feedback, positive and negative feedback loops, systems engineering, and subsystems. Okay, so make sure you familiarize yourself with all of those key terms.